Alright, in this example, we have to find the area of the shaded region right here, given the two central angles CBD and CAD having the measures or having the degrees of 60 degrees and 90 degrees respectively, as well as the two segments BC and AC, which are respectively the radius of this circle on the left and the radius of this circle on the right being 10 inches and square of 50 inches. Now to find the area of the shaded part, it is worth noticing that if we cut it into two like that, the half on the right half belong to the sector on the left. So the sector on the left is that. The half on the left half belong to the sector on the right. So the sector on the right is like that. So if we can find the area of these two segments and then add them together, that's how we find the area of the entire thing. So let's do that. Let's go ahead and find the area of the one on the right first. So we have to draw the sector on the left. So drawing the sector on the left, which is like that. This is the right half of the shaded region. This is the radius, 10 inches. This is B. This right here is the point C, and this right here is the point D. This is the central angle, 60 degrees. And this also has to be 10 inches, of course. Now the area of this segment, we know, is equal to the area of a sector minus the area of a triangle. So that's going to be what? Well, since the central angle is given in degree form, we know the area of a sector is going to be the central angle, which is 60 degrees, divided by the total degree, 360, multiplied by pi, multiplied by the radius square, which is going to be 10 square, minus the area of a triangle, which is 1/2 times base times height. Now, we don't know the base of the triangle for sure, and we don't know the height of the triangle either, so we got to figure it out. Well, that's when it is worth drawing the apothem, which is the distance between the center and the base of the triangle. So in the red right there. And remember that the apothem and the base of the triangle intersect each other perpendicularly, so there's the right angles right there. Looking at this triangle, let's select the top half and try to crank out the height of a triangle, which is the apothem, and the entire base of the triangle. So drawing the top half, let's see, right here. Yeah. I'll draw it something like that. Hopefully you can see that. And right there. This right here is the right angle. This central angle got bisected by the apothem. So this half, which is right here, has to be 30 degrees. Because the central angle is 60 and it gets bisected. So of course, each of the half has to be 30 degrees. If this is 30, this is 90, then by the triangle angle sum theorem, the leftover has to be 60. Now by the 30, 60, 90 triangle property, opposite to 30 degrees is a short leg denoted by a variable, call it x. Opposite to 60 degrees, a long leg, which is also known as the apothem or the height of this triangle, is the long leg, denoted by the formula short leg times square root of 3. Opposite to 90 degrees is the hypotenuse, which is also known as the radius of the circle, denoted by the formula 2 times x. But we know the radius is 10 inches, so we can set 2x equal to 10. Divide both sides by 2 to solve for x. We know that, let's see, over here, x is equal to 10 over 2, which is equal to 5. So the short leg equal to 5 inches. Now with the short leg equal to 5 inches, and the long leg here, which is the apothem, which is also the height of a triangle, is x times square root of 3. Well, we know that the height is going to be 5 times square root of 3. So this is the height of the triangle. There we go. Well, to figure out the base of the triangle, it is worth noticing that this x right here is only half of the base of the entire triangle, because this right triangle right here is only the top half of this entire triangle inside the circle right here. So because this is only half of the base, we have to take this half and we multiply that by 2. So really, that indicates that the base of the entire triangle on the left has to be equal to 5 times 2, which is equal to 10. And that's how we figure out the base. So with the base and the heights now being known, just plug them in to this formula. So the area of the segment is equal to 60 degrees divided by 360 multiplied by pi multiplied by 10 inches raised to the second power minus 1 over 2 times the base, which is 10, times the height, which is 5 times square root of 3. Well, let's simplify a little more. 60 divided by 360 is 1 over 6. 1 over 6 times 10 raised to the second power, which is 100. So we got 100 over 6. 100 times pi over 6 minus, let's see, 10 times 1/2 is 5. 5 times 5 square root of 3 is going to give us 25 square root of 3. So this is equals to, let's see, 100 times pi divided by 6 can be simplified down to 50 over 3 times pi minus 25 times square root of 3 inch square. So this is the area of the segment on the right of the original figure. So it's this one right here. Now let's find the area of the one on the left. Drawing the picture of the left half is probably going to look something like this. Hopefully you guys can see that. And point right here, this is the point A. And like that. So the shaded part here is the left half of the shaded region of the original picture. And this is the radius, square root of 50 inches. This is the point A, this point here is D, and this is C. And of course, this radius here is also square root of 50 inches. Okay, well, same thing, you know, the area of a segment. Oops, and I have to note that this is 90 degrees, so that's the right angle. The area of a segment is equal to the area of a sector minus the area of a triangle. But we know the area of a sector is equal to the central angle, which is 90 divided by 360 times pi times the radius square, but the radius is square root of 50, so that's square root of 50 square minus the area of a triangle, which is 1/2 times the base times the height. So that's BH right here. But how do we find the base of the triangle and the height of a triangle? Well, same as usual. You know, we draw the apothem inside this triangle here on the left. So by doing that, the apothem intersects with the base of the triangle perpendicularly. So there's a right angle right there at the point of intersection. And the apothem also bisects the central angle of 90 degrees. So that means this half of the central angle is going to be 45 and this half is going to be 45. So looking at this entire triangle, I'm going to go ahead and select the bottom half and draw it out. So maybe I'm going to draw it right here. Oops, wait. Yeah, like that. And this right here is supposed to be in the red. That's the apothem. So this is a 90 angle. This angle right here is only half of the central angle. So this has to be 45. Because again, the central angle got bisected. If this is 90, this is 45, this has to be 45. By the 45, 45, 90 triangle property, opposite to each of the 45-degree angles is the short leg, denoted by the variable, let's call it x again. Yeah, let's call it x. Opposite to 90 degrees is a hypotenuse, which is also the radius, and it is denoted by the formula x times square root of 2. But we know the radius is also equal to square root of 50, so we get to take this formula and we set it equal to 50. So solve for x by divide both sides by square root of 2. We know that x is equal to square root of 50 divided by square root of 2. Rationalize the denominator by multiplying both the denominator and the numerator by the denominator square root of 2. We're going to have x equal to square root of 50 times square root of 2 over, well, square root of 2 times square root of 2 is just going to be 2. So square root of 50 times square root of 2, we get to put it under one common root, which is square root of 50 times 2 divided by 2. Well, x is going to be equal to, let's see, square root of 50 times 2 is going to be square root of 100 divided by 2. We know square root of 100 is going to be 10. So we get 10 divided by 2, which is equal to 5. So x is equal to 5. This right here is equal to the height of the triangle. So 5 inches is the height of the entire triangle. Now, what about the base of a triangle? Well, this right here is only half of the base of the entire triangle. So since half of the base, since half of the entire base is 5, then the entire base is going to be this half multiplied by 2. So that means base of a triangle is equal to 5 times 2, which is equal to 10 inches. So guess what? We have the height, which is 5 inches. We have the base of the entire triangle, which is 10 inches. To take the base and the height and plug it in here. So that means what? We are going to have, let's see, I'm going to rewrite the formula again. 90 divided by 360 times pi times the radius, square root of 50 raised to the second power minus 1/2 times the base, which is 10 inches that we found just now, times the height, which is 5, like that. So that's going to be what? Well, let's simplify a little more. 90 divided by 360, that's going to give us 1/4. Keep the pi. Square root of 50 raised to the second power means that the exponent 2 and the square root automatically cancel out, so we're left with just 50. Minus 10 times 5 is going to be 50. 50 times 1/2 is going to be 25. So this is equal to 50 pi over 4 minus 25. This can be simplified out even more by recognizing the fact that 50 pi over 4 can be simplified out to 25 over 2 times pi minus 25 inches square. Yeah. So this is the area of the left half, and the right half is 50 over 3 pi minus 25 times square root of 3 inches square. So that means the area of the entire shaded region is going to be the sum of both of those segments, the right segment and the left segment. So we take this value and we add this value. So that means the area of the shaded region, capital A sub shaded, equal to the area of the left half plus the area of the right half. But then again, we know that the left half is, where is it at? Yeah, the left half is this, 25 over 2 pi minus 25 plus the right half. And we know that the right half is 50 over 3 pi minus 25 times square root of 3, like that. Well, let's see if we can simplify this even more. Let's see. We can factor out a 25 from here, so factor the 25 out. We're left with just 1 over 2 times pi minus 1. Plus, well, we can factor out a 25 from here. So factor out the 25. We're left with just 2 over 3 pi minus square root of 3. And we can factor out a 25 even more. We're left with just, let's see, 1 over 2 pi minus 1 plus 2 over 3 pi minus square root of 3. So, you know, put a minus 1 and minus 3 together and combining like terms to pi. We're going to have 25 over, let's see, 1/2 plus 2 over 3. Well, that's going to be 3 times 1, which is 3. 3 times 2, which is 6. So we get 3 over 6 plus 4 over 6. Or 3 over 6 pi plus 4 over 6 pi is going to be 7 over 6 pi minus 1 minus square root of 3 inches squared. This is the area of the shaded region.